All right, welcome back everybody. Today we have a rather interesting repair series here. I'm going to do two chassis in one video, hopefully. In this box we have a K7000 and a universal chassis. So here's the scoop. The K7000, let's zoom in, probably has a bad HOT, voltage regulator, and at least a couple of large resistors. There were some strange whining noises coming from it prior to the circuit breaker tripping. The owner of this tried to do some repair on his own and put a circuit breaker in place of the fuse because it kept blowing fuses. So that's what the reference is to the circuit breaker tripping. I did the best I could with the jumpers, bridging, missing traces. Oh, that doesn't sound good. The universal chassis, it's blowing the fuse. I was assuming the two transistors that have been removed were suspect. I hope they're in there somewhere. When the fuse blew, I didn't have a replacement, so I went to the standard fuse holder as a temporary fix. Hope you can get the extra goodies here. He included a G07 flyback and cap kit and a 7000 flyback, but it came here from Bob Roberts, so the chances of it being good are about 50-50. Thank you very much, Bill. So let's get the 7000 out of here. Let's get them both out of here and just take a look. We'll zoom out here. There we go. All right. And let's see what we got. Okay, 7000's on top. Lost. Let's toss this in there. And packaged fairly well. Good to see that. And all of the pots have been pushed down, so they're flat on the board, so that's good. They all appear to be okay. That's good. That's good, that's good, that's good! Alright, let's take the 7000 out of here. And there's no fuse in it. This is another one with the P723 board. Huh, R101 is different from what I'm used to seeing. Well, let's take a look at it later. For now, oh geez. Well, there's definitely plenty of solder there. And there's a jumper here for the voltage regulator. Pin 5 doesn't get used. Pin 3 isn't even soldered in. We'll look at it here in a minute. Now the universal chassis. Oh, hey, spare parts chassis. I forgot he was going to send that. Well, look at that. Spare parts, all right, well that's good. I've got maybe a dozen of these laying around, so. And this has a fuse in it, but it's the wrong fuse. Again, someone put what looks like a fast blow in place of where a slow blow is supposed to be, so that was the problem. But since it's a parts chassis, we're not going to worry too much about that. And then down here should be the universal chassis, yep. I think out of curiosity's sake, I want to start with the universal chassis to see what we can get going on that. So it's blowing the fuse, and I'm curious to see if we can figure this out. Now there's no guarantees here with this, but I was interested to see if I can get this working. Okay, set that aside. I'll put the 7000s aside. I want to start, the 7000 should be easy to figure out. I want to start with this guy here. Well, he said here that I assuming the two transistors that have been removed were suspect. Two transistors. Well, there's okay. So we've got this one here and this one here. These have both been removed. This one and this one. So one of these is the HOT, and I'm assuming it's this one because our width cap, this is probably our width cap right there. This is probably our HOT, and this is probably our voltage regulator because it's coming off of over here. So voltage regulator, HOT most likely. But we can test those rather easily. So let's just remove them here. And we'll mark the voltage regulator so we don't get them messed up. Actually, the voltage regulator is the shorter leg one, so we'll see what we can figure out here. So zoom out a bit. All right. So voltage regulator is this one here. We got a 2508 Alpha Foxtrot and 2508 Delta Foxtrot. Well, regardless, let's just make sure that they're not shorted. All right. Well, gone. And our suspect HOT gone. Oh crap. Do I have replacements for those? I don't know. How can both of those be gone? There's something seriously wrong to have done that. Man, every which way these are. Wow, okay. Well, you know, as luck would have it, I actually have one of these universal chassis just sitting here. So I wonder, nope, I will not be able to use this one because this one has the standard bottle transistors on it for the HOT and the voltage regulator. These are bottle transistors, so I'm not going to be able to use those. So that's a bust. I have to wonder, do I have anything that I can rob these parts from? I have to dig through my parts stash here. Give me a second. Oh, I think we may have a winner here. I have one of these. This is for a 19-inch chassis. This is one of those universal ones. This, I think this had collapse. I think this had vertical collapse right out of the box. And I never really was interested in trying to fix it. So I just threw it on the parts pile. I didn't have any interest in trying to repair these universal chassis because no one really has them, and they're so cheap that if it died, you just replace it. So we happen to have our voltage regulator over here and HOT right there. So let's see if we can just rob these from here, put them in this one, and go through and do some more testing of various components and see if we can get it figured out. So yeah, I got this rather cheap, and right out of the box, brand new, was in collapse. So much for QA testing on these things. And you can always tell which one is voltage regulator and which one is HOT by their location on the board. So if we look here, right here by the right here by the flyback and the horizontal width coil, I guarantee it's the HOT because it's right here by the H width coil and all that stuff. So this is our horizontal off the flybacks, the horizontal circuit going through the HOT and all that. And then over here by the power supply section where the filter cap is, our voltage regulator is right by the filter cap. So, and our B plus resistor is likely this one here. So you can usually tell, get a good idea of where these components are and which ones they are based off their location. So let's see if we can zip out this voltage regulator. Easy enough. And HOT, easy enough. All right. So now we'll set this back over here on the parts pile. And see what we can figure out here. So this was our HOT. This is our voltage regulator. Let's test them out here. Well, that's not good. We can put a regular HOT in if our voltage regulator is okay. 0.48. Hold on. Okay, so this one reads only this way. Come on. Okay, 0.489. Oh, you can't even see. Sorry about that. Let's zoom out. Okay, so yeah, it doesn't read it all that way. So we got 0.489 or 490, and I'll open to that. So yeah, but the one we pulled out of the HOT is shorted. So we're going to just put a regular standard HOT in the circuit. So we're going to put this in. Hopefully it works. It's not shorted, so that shouldn't be a problem. And this chassis, that chassis I pulled these out of, it did fire up and work. It was just collapsed. So we're going to resort to extreme measures here. We're going to put this in here temporarily as our voltage regulator. Come on. Well, let's just put this in here. Well, you know what? Isn't there supposed to be... I'm going to put an insulator on there. I don't know if it's supposed to be insulated or not. So to prevent anything from being blown up due to non-insulation, I gotta find my bag of insulators here. Bear with me for a moment. I'm sorry. It's not that. It's there. We go. Got it. Let's throw a couple of insulators on here just to make sure. One, two. Buckle my shoe. Why is nothing ever easy? Can someone, there has to be some type of scientific explanation as to why the simplest task is always the most difficult. There we go. Okay, and before we solder that in, I think it's probably a good idea to look that up. D1402, let's actually look that up here. let's see here. D1402. Data sheet. Okay, this is power transistor. Yeah, so this is our voltage regulator. So, yep, power transistor. So there's our voltage regulator. Now, if we were to look up this one that was bad, C4769. Let's do C4769. Data sheet. Yep, horizontal deflection output. So my theory was correct. So this was the HOT off that other chassis, but it was actually bad. And that's our voltage regulator. So we can go ahead and solder that puppy in. Turn my fan on. Well, sometimes easier said than done here. Because it's easier said than done. Alright, now that the now that the voltage regulator is installed, let's see if it reads the way we expect it to now that it's installed. Should be 0.118, yep, because it's reading through the B+ resistor. And we don't have anything on the other side. Yeah, 0.447. So, yeah, I think that's good. Speaking of B+ resistor, let's make sure it's not bad. What is that? 40 ohms is what that says. 140. Oh, 140. Yeah. So B+ resistor is good. We're at 138. And voltage regulator seems okay. We're at, I don't know what they've got this B+ dial to. So I'm worried that someone was adjusting it. I think just for safety's sake, we'll set it right in the middle and adjust it as we need. I have no idea what the stupid reading is supposed to be. You know, it's either going to be 117 or 120 if I was a bet man, so we'll put it somewhere around there if we get it working. And, okay, so that's soldered in. B+ resistor is good. That's good to go. Let's get a HOT in there because those are all bad. Let's get an FJL series in there because the FJL series is compatible with pretty much everything. HL-2529 is what we're going to use. My intention was to get both of these working in one video, but that might have been a little pipe dream because I don't want a 2-hour long video. So depending on if we get this working rather quickly or not, we may have to make a 2-parter instead. Now, as I'm looking at this, look at this discolored resistor. Look at this discolored resistor. I want to know what that reads after seeing that. In circuit, this discolored resistor reads 390 ohms, but I don't know what it's supposed to read. It's supposed to be 390, 2-watt 390R. So that's not bad. Okay, so that's not the issue. Let's get our HOT installed with an isolator. You know, I probably could have just checked to make sure that if this isn't grounded, if this isn't on the ground plane, I don't need the insulators, but I'm going to use it anyway. Going to use it anyway. Alright. So let's get that installed. Okay. Then where'd my trash can go? Where the hell over here? Ah, come on. There it is. Alright, so let's check it in circuit here. .41 and 0.41. So we have a functional voltage regulator and a functional HLT. Let's make sure that we don't have anything else visually wrong. That discolored resistor checks good per the screen print on the board. Any broken pots? There's some bent ones, but nope. No broken pots. Let's check our solder joints. Most of these universal chassis have some pretty bad solder wave work, but okay, we don't have anything wrong with the header pins for the yoke. I don't see anything overly obvious. Okay. There's really just not much to these, is there? Flyback was way up too high. B plus resistor checked good. Well, I don't really know what else to check. We can check the rectifier diodes here, make sure none of those are bad. Nope, those are okay. Well, alright. What's this say? 2 amp, 250. I think these are the fast blow though. So let's put a fast blow 2 amp on there. Which I just happen to have right here. Okay. Let's make sure we have continuity down here now. Oh, put that back. Yep, okay. Well, what do you think, boys and girls? Should we just go ahead and try it? I think we should just go ahead and try it. Because the worst thing that'll happen is, let's see, this is going to be our linearity. This is our linearity adjustment because it's right by the vertical IC. This one here, linearity adjustment. This is our B plus, absolutely, because it's by our filter cap and power supply. Let's make sure our width cap isn't shorted, which is going to absolutely be C4 here. They have it labeled. Let's make sure that that's not shorted. Nope. Okay, well, let's try it. Let me get all this cleaned up, get it on a tube. I'll come back, we'll have it set up and ready to turn on and see what happens. Okay, we are hooked up again rather precariously. I don't have the correct type of connection here for the AC input, but we're hooked up. Nothing's touching, nothing should explode. I don't have a video signal because we don't need a video signal to see if it powers up. We're just checking to make sure it turns on. We hear high voltage energize. The fuse does not blow. And we're looking to make sure it operates. I got the yoke hooked up right there. I've got the anode wire and all that jazz. So we are ready to go. Got the ground hooked up. So we're just going to see if it turns on, if the fuse goes, or what happens here. So let's find out. 1, 2, 3. Hey, came right on. And we've got smoke. Something over here went kablooey. You see the smoke in the air there. And something, oh, looks like our vertical IC is smoking. Don't know if you can see that, but our vertical IC is popped. It's actively smoking. Not sure if it comes through on the camera, but it's so. Yep. So vertical IC is done. Now whether that was a result of something previous or I don't know. Should I even attempt to turn it on again? Does it still power up? Yes, it still powers up, but so the blowing fuse is now repaired, but now our vertical IC took a dump. So let's see if we can figure that out. Okay, so after getting this off the tube and taking a closer look, it turns out that it's not the vertical IC that was smoking, it's this resistor down here that smoked. This resistor right here, R27 it looks like. This resistor smoked itself. Now the problem is I have no clue what rating that is supposed to be. Absolutely no clue what that's supposed to be. That's coming directly off our vertical linearity pot. I never messed with it. Put it halfway. But that comes right off our vertical linearity pot. Right there. And it's smoked. I got flaking pieces off of it. So we got to try and figure out to the best of our ability what that's supposed to read and why it did that. Now, is this transistor bad? Let's see if we can read that one. All right, so let's read this one here. Nope, that's fine. That resistor is right here. That resistor is right here. And that's, yep, directly tied into our vertical linearity. And if we go to ohms and read across it, 231 ohms, but the resistor smoked, but we didn't have it on long enough to probably make it go open, but it shouldn't have smoked in the first place. So it looks like that it's tied to the vertical linearity, but it's also running to, let's see, it goes across to the vertical IC, which is on that trace there, which is part of that cap. But it runs up to across there, which is across C17, which I don't think is bad. You know, it's possible that it just did that because I didn't have a video signal hooked up. You know, the resistor isn't open. We should probably replace it, but I don't know what the reading is supposed to be. 230 ohms. Well, it's not open. I think let's try it again. Let's set all of our pots to the center. They don't have. This is 100% Chinese. There's no. I don't know which of these pots are what. These are okay. This is brightness. These three are red, green, blue, but the rest of these, they're all in Chinese, so I have no idea what they are. But we'll put them all to the center. Not even all the same type of pot. Okay. Well, let's try it again with an actual video signal hooked up. Because maybe it did that because there was no video signal hooked up and it didn't like it. I mean, some chassis are like that. Without a video signal, they don't get along very well. This one is supposed to be 390 and it's climbing up. It was 389 something or other before. But it's only 347 now. And that's directly tied to our vertical. So this resistor that's supposed to be 390 is going right to the vertical winding. This one is 1 ohm. Yeah, 1 ohm. 17. 0. Oh, 0.075. 2.7K. It's 3.2, but that's in circuit. Well, let's remove this resistor and verify that it's not open out of circuit, which it shouldn't be. Okay. Out of circuit, this resistor reads 390 ohms. Okay, now find that again right here. Okay, now we should take R27 out of circuit in an effort to be correct. We don't want to take any shortcuts and damage something else. Okay, 27's out of circuit. With it burned up like that, I just want to make sure that it's not actually open. And we're reading through something else here. 230 ohms. Okay, well, it's not open. So, and we didn't have it on long enough for it to burn up completely. And I have no idea what it's supposed to read. So, based on that, let's try it again with an actual video signal and see if it makes any difference. So here we go. Okay, so we're hooked back up now. I've got the video signal. It's got one of these newfangled type of connections there that I have to use that thing for. So we're all wired in, and let's see what happens now. 1, 2, 3. Okay, it comes on. We got the green light now right there. And do we have any? Whoa! Smoke City! Holy cow! Where's that coming from? I can't tell where it's coming from. We're going to turn it back on again, see if we can figure out where that smoke's coming from here. 1, 2, 3. I can't tell. But we got a whirlwind of smoke. And I don't think it's the resistor. I swear it's that vertical IC. I swear that's where it's coming from. Oh, sorry about that. My phone rang and I had to answer it. It took a while and I forgot where I was at. So I went ahead and removed the vertical IC here. And as we can see, it is toast. it let all of its liquid out, and it's cracked right across here. I don't know how close I can get. Right here, it's all cracked open, and it let its nice little liquid out. So that smoke was coming from this, and this may have been the reason why that resistor burned up. But I actually have some of these, if I recall correctly, in my bag of 07,000 parts, and yeah, this one has a different type of system. What about this one? Same thing. So I actually have a bunch of these. Let's take a look. Let's see, this is 7840. Oh, 7833. I bet you I can use that, though. I bet you I could probably use any of these, quite honestly. What is that one? That one is 70. Yeah, these are 7833. We'll try a 7833. I'm almost certain the difference is negligible, but I'll look it up and verify first. But we'll try a 7833. I'll make sure the data sheet's the same, and if it's close enough, then we'll use that one. So let me look that up. Assuming it works, I'll have it installed, come back on the tube, and we'll see if it works at that point. Stay there, you. Alright, the 7833 was indeed a valid replacement for the burned up LA7840. So I got it installed, everything's hooked back up. Let's see if this one smokes. Here we go. 1, 2, 3. And we've got no smoke so far. No video so far. I can hear it making noises. We got the LED on as a valid video signal. Oh, it's working! It's working! I don't know which one of these is. I think this one here is brightness. Aha! It works! Yes! I need to make some adjustments, but we had a bad HOT, a bad voltage regulator, and a bad vertical IC. Oh no! What just happened? There were lights coming on from under the chassis. Oh, that wasn't good. Let's see what 1, 2, 3. Oh, now it's dead. Did the fuse go? Ah, the fuse went. Maybe I celebrated too early. There was some type of... I saw some type of light come out from under the chassis. It's insulated. There's nothing touching, trust me. Well... I can't use a circuit breaker because it needs to be a fast blow, not a slow blow. Circuit breaker is a slow blow. Let me do some more troubleshooting here, see if maybe it was just the B plus set wrong. Let me find another fuse, get it going again, and let's check the B plus. Okay, so I took the chassis back out, replaced the fuse, and it turns out that the HOT, the HL-2529 that I put in there, we saw the chassis operating for about 30 seconds and it zapped itself dead. It turns out that the HOT died, it got shorted out, and then it took the fuse. So I put a new fuse in, put another HOT in there, and then I tested it again off camera and it zapped it out again. So something is eating the HOT. Now we know the chassis is working because it operated for about 30 seconds and then the HOT died. So I think what's happening is I don't think that the HL-2529 is a correct replacement. So this is the one I put in there the first time that shorted out. Now that one is shorted out again as well. I put another fuse in, but this time I went through all my parts and digging through the bags, and I found the correct replacement. So the original HOT, I don't know if we'll be able to see it here. It is a 508 Alpha Foxtrot, BU2508 Alpha Foxtrot. The 2 is kind of insignificant, but it's basically BU508 Alpha Foxtrot. I don't know if we can see that, but it's BU508 Alpha Foxtrot. Now I found 2 correct replacements. BU508 Alpha Foxtrot. So this is the correct replacement, the same one that that was taken out originally. So now I actually have 2 of the correct ones that came with this from the factory. So I'm going to take this HL-2529 out and put the correct 508 Alpha Foxtrot in and see if we can get it to work longer than 30 seconds. And also I found out through some research that the B plus is supposed to be set to 115. And there's a resistor here, R6, on this leg of R6 right here. This leg, that's where you read your B plus, and it should be 115 volts DC. So we need to set that to read 115. We'll put this in there, turn it back on, and see if we get it to work longer than 30 seconds. So let me do that. We'll come back, I'll be on the tube and we'll test it. I'll have the B plus ready to test and hooked up with the meter, and we'll see what we can get with the correct HOT installed. Okay, so it's a number of hours later. I've been fighting with this and fighting with this and fighting with this, and I was just about to give up and call it a no fix, but it turns out that all of that effort I spent earlier with changing the HOT out to the HL-2529 was a wasted time, because it needs the correct rating and style and type of HOT. These might be kind of universal for everything else, but for the, well, I guess for the universal chassis, they don't work. So after finding the correct 205 Alpha Foxtrot, is that what it was? Let me see here. Yeah, 508 Alpha Foxtrot. The original 508 Alpha Foxtrot we know was bad, but it turns out that this chassis, more than any other one, needs a very specific HOT. So I put that correct one in there, and then it ran and ran and ran and gave me no problems, except after about 5 minutes, the image started to get bluer and bluer and bluer and bluer until it was just an all completely blue screen. So I troubleshot that, figuring it was a neck board issue, and sure enough, the transistor right there, you can see that it's different from the other 2 because it's shorted out. This little guy right there is shorted out. So after I replaced it, I still had an all blue screen. I thought, okay, great. So based off my previous knowledge about how these operate, the circuitry for the red, green, blue, there's 3 transistors right there. Not the 3 over, where's my finger at? Not these 3, but those 3 right there. You can see that 2 of them there, the one in the middle and the right, are taller than the one on the left, because it turns out that 2 of those were bad. After replacing the most outboard one, I got an all green screen. After replacing the middle one, I got all of the correct colors. So this thing had a blown vertical IC. It had a shorted voltage regulator. I think that was the Delta one here. No, that's the HOT. So we had a blown vertical vertical IC, blown vertical IC, shorted HOT, shorted voltage regulator, and then this was an HOT I think that I had that was already shorted, so we don't need to include that one. I'll throw that away. And then these 2 here I put in, the HL-2520s, these ended up being incompatible. That's why those got taken out. And then we ended up having 3 bad transistors for color. So a blown vertical IC, a bad HOT, a bad voltage regulator, and 3 bad color transistors. After getting all that replaced, let's turn it on and show you that operational. I also found in some various posts on the internet and research that the B plus is supposed to be 115. So I got the B plus pot adjusted to reach 115. So after changing out all these faulty components and getting the B plus set to 115, it fires up and I got MK running. There you go. The only problem is that the image is way too wide, super wide. You can see the MO is cut off, and over here it's just super, super wide. And you can see that there's kind of a halo around the lettering. If I turn the brightness pot down till that halo goes away, it looks really good, except it's too dark. I mean, this looks really good, but it's too dark when the game boots up. So there's it may be a monitor problem. I mean, these things are meant to go on multiple different styles of monitor, but you can see that it is now operational. Let's get past this here. If I can find the controller, there we go. All right. So see, you can see it's too dark, so I need to turn the blue down a bit. And that's the brightness. We'll turn the brightness up and the blue down slightly. So there you go. Well, see, now it's too green, but regardless, it doesn't ultimately matter. That's a bit better. Okay, so I mean, you can see it's working. I got it working. Just a lot of effort, a lot of gnashing of teeth, I should say, gnashing of teeth and hair pulling out, and I got it operational, and it looks fairly good. However, it's way too super wide, and there's an adjustment for that. There is a jumper right there for narrow or wide. I have it on narrow, and there's an adjustment right here for width. This pot right here is the width pot, and you can see that if I turn it this way, it gets wider. Now if I turn it this way, it gets narrower, and that's the narrowest that it gets, and there's no way to make it more narrow. So the only way to fix this would be to change out the width cap, and I'm 99.9% sure the width cap is that one right there, but I don't know for sure. And also I don't know what tube that the person that owns this is testing it on. So if they get it back working and it's too wide, they'll need to change that width cap out. But as you can see, it is now repaired. We had a shorted HOT, voltage regulator, vertical IC, and 3 color transistors. After getting all that fixed up and operational, did I even turn that on? No, look, 115.4, perfect. So there you go. Now I think I spent so much time on this turned out to be a much longer than I expected. I'll probably have to do the K7000 in a separate video. But for this one, we are successful in the repair of this universal chassis. So, hopefully you learned something. Thanks for watching. Like, share, and subscribe. And stay tuned for the K7000 in the next video.